Hello, welcome back. In this video, we'll be talking about how to get these numbers right here. But I will have to first tell you, I actually do not know how to get the equalities. So I'm sorry about that, but I'm really happy because I finally saw how to get these two numbers. And I will have the reference in the description for your convenience. And if you do know how to work out some computations to get the equalities, please let me know as well. Thank you so much. Now, here we go. Right here, if we want to solve x to the x to the x infinitely many times. For this part, we should technically do this in order. What do I mean by that? Have a look. We should technically start with x, and then the next one is x to the x power, yeah? And then the next one is x to the x to the x power, and so on, so on, so on. Well, right here we have infinitely many x's. That means you continue with this procedure, you continue with this sequence, and you take the limit, right? This is the limit of functions, and what we can do is we can define y1 to be the first, which is just x, and then y sub n plus 1, namely the next one. How can we get the next one? Well, how do we get this? You can just look at the previous, namely x to the x power, and you put that to be the power of this x. So when we have yn plus 1, this can be written as x to the previous term's power, namely yn. So that's pretty much it. So you can define a sequence like that. Very cool, huh? However, if you think back to the previous video that we did, x to the x to the x infinitely many times, this is equal to y. Let me put that down right here for you guys again. Starting with x, and then you know the rest of the x's will be in red. Like this, This right here is equal to y, perfect. But we also have infinitely many x's there, so in that case, what we can do is we can write it as x to the y's power, that's equal to y, yeah? And just like the previous video, we may be able to do something about it if y is equal to 2, right? Now, have a look right here. The left-hand side, we have x to the y's power. And please look at the y as the input. Look at the y as the input. When we do that, you see the output right here is also y. This right here, it's a concept of a fixed point. Let me give you an example first. Suppose I have a function, but in this case, our y is the input. So let me purposely use y right here. Let me tell you, suppose the function is y squared minus 4y. And I will tell you guys a fixed point. Let's look at f of 5. What happens if we plug in 5 into y? Well, this becomes 5 to the second power minus 4 times 5. And this right here is 25. This right here is 20. Subtract them, you do end up with 5. And as you can see, you entered it 5 and you got 5 as the output. So the input and the output are the same. This is the idea of a fixed point. So use this idea. There's actually something called the fixed point convergence criteria, and that's what I found in the article in the description. And I will just tell you guys what it is right here, right? This right here will converge if you put the absolute value first, but again, you look at this as your function, and the y is the input. So what you will do is, you will have to differentiate with respect to y of whatever this is. X to the y's power like that in the absolute value. And you have to solve this, make it less than 1. And this is that fixed point convergence criteria. And you see, we have an inequality right here, but unfortunately, I think there's technically no equal sign here. That's why, as I said, I do not know how to get the equal sign. I believe that you have to just test out the endpoints, just like how you do the Taylor series, power series. You get the radius of convergence, but you check the convergence at the endpoints. But yeah, let me just at least show you guys how to get these two numbers. Okay, how do we do the derivative right here? Well, we are in the y world, right? So this is technically an exponential function, some number to the y's power. Let me give you guys an example right here. Let me just remind you guys. dt because I'm using x and y already. Suppose I have some base b to the t's power like so. Differentiating this, we get b to the t repeats, but we multiply by ln of the base, namely ln b. So in this case, we will have the absolute value, and we repeat x to the y's power, and then we multiply by ln of the base, which is ln x, and then we make this less than 1, just like that. Perfect. Alright, this is so crazy. Because we have an inequality with both x and y, how can we possibly do that? Don't worry, have a look right here. This is so cool because you see that we have x to the y's power, and that's precisely equal to the y. So let me just put down the y right here, and then I will just write down the rest. Absolute value, and we have ln x, I will just put it down in black. And then less than 1, like that. Well, still have x and y, but we do have a natural log, right? This times that, we can actually put a y to here and it becomes the power. So this is equivalent to say absolute value of natural log of x to the y's power, and then still make that less than 1. And now what's x to the y? Yes, this part is again just y. Aha! We finally have absolute value of ln y, and we have to just make that less than 1, and we can just solve this inequality the usual way. Perfect. Alright, take out the absolute value. What we have to do is just put this in between of -1 and +1. And now I will just do e to the whatever, not everybody, exponentiation, right? And because e to the whatever, like e to the x is it's an increasing function, so when you do this, you maintain the inequality, right? So here you see e to the -1, and then we have just y in the middle, and then we have e to the first, which is just e, and that's precisely what we talk about right here. We have y, we should also find the x, yeah? So here's the deal. X to the y's power is equal to y. We can just raise both sides to the 1 over y's power. And you see they will cancel to be 1, and we get x equals y to the 1 over y's power. Like that. Pretty good, huh? So what does that mean? That means when we know y, we also know x. X will be in between of, put the e right here and right here, we get e to the 1 over e's power. Put the e to the -1 right here, we get e to the -1, and then raise to the 1 over e to the -1 power like this, huh? But we have e to the -1 in the denominator, we can actually put that up, so this is equivalent to say e to the -1 raised to the positive e's power. And now, what do we do with this? Yes, just multiply the powers, yeah? So we get e to the negative e's power, namely the one that we got earlier. Here's the summary. If you want to solve an equation right here, you have to make sure y is in between of this and that, right? However though, if you happen to have an x value that's in between of this and that, and you put it into the infinite power tower, you actually get a convergent value. And you might be wondering, when we had a cube root of 3, we put it here, how come we didn't end up with 3, but we end up with a 2.4 something? Well, you will have to watch my next video, because again, this right here has so many different parts, and every part deserves to have its own video, right?